x1 row will not be there, or x2 row will not be there, or x3 row will not be there. Fine.
Yes, sir. Now I got it.
See. Okay, so if I do it, then -1, then x naught square, x naught cube, x2 square, x2 square, x2 cube, and x3 square, x3 cube, right? And plus similar fashion, right? But these terms will not be repeated. Now again, if I expand it along first row, first column, so then you will get x1 times x2 square times x3 cube, of course minus x3 square, x2 cube, but we are not very concerned. I am concerned about just this coefficient at present. It will be 1. Fine.
Yes, sir.
So can I assume assignment sheet 3 is done now?
Yes, sir.
Yes,
Okay,
sir.
please open assignment sheet 4 then. Question number 1 to 3 has already been discussed in the class.
Yes, sir.
Okay. Now please read question number 4, 5, 6. Can you do them? At least 4 and 5 first of all.
Yes, sir.
Yes, sir.
Doing question number 4 and 5 means you guys are aware that how to apply Newton's method. That is the only thing. Right?
Yes, sir.
Okay. Read question number 6. Have you guys solved question number 6?
Yes, sir.
What is the coefficient of x square?
3.5.
Does everyone got the same answer? Does all of you got the same answer?
Yes, sir.
Okay, good. So we are clear with question number 6 then, right? What do we need to do? We have to insert one more point, probably.
Sir, 2 point, I think.
Now you can add 2 points because you want the last one to be 0, right?
Yes, sir. Yes, sir.
Okay, so that will not change because okay, you can do that because we want the last one to be 0. It is perfectly fine. So then you at the end we just need the above upper triangle stuff, something of this sort, right? And we are already having values here. So basically, if I go with this 0, 1, 2 is given, 3 and 4, then f0, f1, f2, f3, f4. Then we do something of this sort. Right? And we just need these values. This one, some value here, some value here, and here, right? That's what we need the coefficients when we are doing the polynomial interpolation.
Yes, sir.
Okay. So proceed to question number 7. Have you tried question number 7?
Yes, sir.
Are you guys able to do it?
Yes, sir.
Is there anyone who need an explanation for question number 7? See, you have to do the back substitution here to get all the values. Not even that. What you can assume is you can assume P of 0 to be some constant A, del P of 0 to be some constant B, and then you can proceed because you will have some polynomial P of x as A plus x times B plus x into x minus 1 upon 2 times del square P of 0 plus x minus 1 x minus 2 upon 3 times del cube P of 0 3 factorial, right? Just plus and so on, right? That's how have you solved it? Is that the way you guys have solved this problem?
Yes, sir.
So basically, what do you need to do? When you have your polynomial P of x, then you need to find P of 10, P of 11, P of 12 from that polynomial. So it will be P of 10 will be something A plus B plus something. It will A plus, sorry, 10B. It will be some A plus 11B plus something. That will be A plus 12B plus something, right? So what do I need to have? Del P10 and del P11. It will be B plus something. It will also be B plus something. And then del square P of 10 will be nothing but this, subtract this. So if I say it is some B plus some R, it is B plus S. It will be S minus R. Fine.
Yes, sir. Sir, what is the answer?
I haven't calculated it completely.
Okay.
See, if you know the way, you can anyhow find the answer, right? So the method is clear, like how to approach this question. Is it clear to everyone?
Yes, sir.
Okay. Question number 8 is very trivial, I suppose. We are already given a polynomial of certain degree, x to the power n. So tell me what will be f x naught x1 up to xn.
and factorial.
But are you aware that f of x naught x1 when we do this, then there is one n factorial in the denominator also.
Yes, sir.
So basically it will be
1.
right. And what about the next f x naught x1 up to x of n plus 1?
0.
Right. Is this thing clear to everyone that how f of x naught x1 up to xn is 1 and x naught x1 up to x of n plus 1 is 0?
Yes, sir.
Yes, sir. Clear.
Sir, here we are using Hermite-Genochi methods. Can we do this without using that
Which method are you talking?
Hermite?
No, you don't need to do Hermite here. It is just a trivial thing that you can all. I think it must have been taught in the class that f of x naught x1, if you are taking x naught x1 up to x of n, it is more or less related to f n Fn of x. Fn of x means the nth derivative of f.
Okay, sir. Okay, sir. Yes, yes, yes.
Is it clear?
Yes, sir.
Okay, question number 9 is, I think, again discussed in the class.
Yes, sir.
Okay, I am not very sure about question number 10 because I'm not aware about the notations ma'am is using here. U0, U1, U2. So I will discuss this question with her and we'll get back to you. If you guys have some idea about this, you guys are open to discuss it here. Are you aware about this notation, or somewhere ma'am have said anything about that in class? What is U0, U1?
Sir, in Hermite interpolating polynomial, ma'am introduced UI.
But here ma'am has given this in Newton's interpolation. I will ask her if it is related to the Hermite one only, then we can discuss it in the next tutorial for sure. So we are just left with question number 11. So are we aware how to proceed for question number 11? Have anyone tried it? Do anyone of you have tried question number 11?
No.
Okay, let me do it. It is more or less some interesting question. So define your f of n to be Sn for the time being. Okay. So it is basically nothing but I running from 1 to n I cube, right?
Yes, sir.
And I want some interpolation for this. Now can you do this? You can get f0, f1, f2, f3, f4 and maybe f5. Yeah, it can work. If you start with these one, you will get that gradient f lap, Laplacian f Laplacian 5 f of 0 is 0. So see, when we have any polynomial and we know the value of that function at certain point, so what will we do? What is the then natural thing we do when we are when we are reading some Newton's interpolation? So what do we need to find? F of 0, Laplacian f of 0, it is nothing but error f of 0, f1 minus f0. Then grad square f of 0, which is nothing but f of 1 minus Laplacian f of 0, right? That is how we proceed.
Yes, sir.
Okay. So when you will proceed in this manner, you will find that this thing is 0. And not only for f of 0, do one thing. Start with any f of n. Okay. F of n, Laplacian f of n, f square n, and so on, f5n for any n. You will get this is to be 0. It is already 3-1. If you guys have 5 minutes, then we can discuss it properly.
Yes.
Can we discuss it?
Yes,
Yes,
sir.
sir.
Okay. See, f of n is nothing but summation I cube I running from 1 to n, right?
Yes, sir.
So what will be Laplacian f of n? It will be f of n plus 1 minus f of n.
Yes, sir.
Yes, sir.
It will be summation I running from 1 to n plus 1 I cube minus I running from 1 to n I cube, which is just n plus 1 cube.
Yes, sir.
So let me write n cube plus 3n square plus 3n plus 6. So 1. Right? Laplacian square f of 1 is f of n plus 1 minus f of n, right?
Yes,
So
sir.
it will be again n plus 1 cube plus 3 times n plus 1 square plus 3 times n plus 1 plus 1 minus n cube minus 3n square minus 3n minus 1, right? It will be nothing but n cube plus 3n square plus 3n plus 1 plus 3n square plus 6n plus 3 plus 3n plus 3 plus 1 minus n cube minus 3n square minus 3n minus 1, right? So it will be nothing but, so this is getting cancelled, 3n square plus 6 plus 3 9n plus 7, right?
Yes, sir.
So now if I find this, f of n plus 1 minus f of n, it will be 3 times plus 1 square plus 9 times n plus 1 plus 7 minus 3n square minus 9n minus 7, which is nothing but, so 6n plus 3 plus 9, right? Rest will be cancelled, which is nothing but 6n plus 12, right? Fine.
Yes, sir.
Plus 1 minus 10 cube f of n, 6 times n plus 1 plus 12 minus 6n minus 12, it is nothing but 6 for all n. See, we are not substituted any value of n till now. N f of n plus 1 minus 12 for f of n, 6 minus 6, which is right.
Yes, sir.
So what is my function now? If I want to define it as px is equal to what? F of 0 plus x minus 0 del f of 0 plus x into x minus 1 del square f of 0 upon 2 factorial, right? Plus x minus 1 x minus 2 del cube f of 0 upon 3 factorial plus f del 4 f of 0 and plus 0, right? Because we know that del 5 is 0 for every n. So basically del f, so for this means del n, say m, f of 0 will be 0 for all m greater than equal to 5, right?
Yes, sir.
So now you have the values here. What do you need to do? Just substitute n is equal to 0 here, here, here. So you will get a polynomial of degree 4. Is this clear now? Do I need to solve further here? Do I need to solve more, or is it clear now?
No,
You
sir,
just
it
need to
is
substitute
clear.
the values. So can you assume that we are done with assignment sheet 3 and 4 now?
Yes, sir.
Yes, sir.
Okay. So
Hello,
since
sir.
yes.
Sir, what about question number 10? You not, sir.
Yeah, I will discuss it with ma'am and we'll get back to you for sure.
Ma'am, sir, if U naught is a function at x naught, then we can easily find out, sir.
See, I will not comment on it because I am not aware what is in her mind when she is plotting this question. Okay.
Okay, sir.
So let me discuss it with her first of all. So except question number 10, are we clear with assignment sheet 3 and 4?
Yes, sir.
Sir, in question number
Yes, sir.
5, backward formula will be same.
Yes, at the end the interpolation, the polynomial will be same.
But sir, we do need to find the formula from both forward and backward interpolation, right? Or we can
Yes,
directly write it.
No, you have to do it because they
Okay,
are
sir.
asking you to do the backward interpolation. You can't say
Okay,
ki,
sir.
since the polynomial will be same and we are getting f of 4. No.
Okay, sir.
Okay. Don't worry. In the exam, you will not be asked both to find the polynomial with both the cases from the forward also and from the backward also. It is just given so that you can have at least one question for practice for forward interpolation and for backward interpolation. But please remember this, if it is explicitly written in the question to use some method, I have told this thing when we are doing the approximation, that bisection and Newton-Raphson method also. If you have given some particular method that you have to solve this by this method, then please do not use any other method. You will not fetch any mark. Okay?
Okay, sir.
Okay, so since I do have a meeting from 3:15, so we should wrap up for today now, and we are meeting at 11 tomorrow, right?
Yes, sir.
Okay. You guys can leave now.